Hi, in this video I'm going to use R to answer a hypothesis test. So we're going to do hypothesis testing for the proportion. And this is one sample test. So we have only one sample of data. And the answer, and the question I'm going to try to answer is given by this problem here, the script note here. So it says the worldwide market share for the Chrome web browser was 26% in a recent month. Suppose that you decide to select a random sample of 200 students and you find that 60 use the Chrome web browser. So you're collecting a sample at a particular university. We're going to pretend this is at your university. You ask 200 students. This is a representative sample of the students at the university, and you find that out of the 200, 60 of them use the Chrome web browser. So the question that we're trying to address is there evidence that your university, the Chrome web browser market share, is greater than 26%? Right? All right, so we're going to start defining the null and the alternative hypothesis for this question. So I'll write it here on my Chrome, on my RStudio. So I'll say, okay, the null hypothesis. And I restated the question here. So is the Chrome market share at the university greater than 26%? So the null hypothesis is always the opposite to the main thing that we're trying to prove or discover. So in this case, it's going to be, well, the market share, so the Chrome market share at the university is less or equal, so always includes the equal sign, 26%. 26%. The alternative is going to be exactly what we're trying to prove, or the evidence that we're trying to find. So we're going to say the Chrome market share at the university is greater than 26%. So notice that here we do not include the equal sign. So the alternative hypothesis never ever includes the equal sign. It can have less, it can have greater, or it can have no equal, but never the equal sign. So now that we have the hypothesis, we are ready to run the test. And I'm going to do first the ztest. So I'm going to enter the data. So I'm going to enter the data, and I'm going to define some variables for that. So I'll have, well, first of all, the sample size. So the n size, I call it. Sample size of my sample is 200. The number that said yes, so I can call it the number of yes, or the number that said Chrome yes, is 60. I can calculate the sample proportion then based on that. For my particular sample, what was the proportion? So I'm going to calculate that. It's the ratio of those two. So it's going to be the n Chrome divided by the n of the size. If I want to see what the actual number is, I'm going to run this piece of code and see what that number is. So, okay, my answer here is 30%. So in my particular sample, the sample proportion, so the proportion of users that use Chrome is 30%. So, okay, so it seems like I have some evidence, but the big question is that evidence enough for me to conclude that at the whole university, the market share is 30%, or the market share is greater than 26%. They give me some significance level, or if they don't, we can go back and take a look to the problem. So the problem, there is no significance level, so I'm just going to use by default 5% as my significance level. So I'll use that way. I'm coming back. I'm going to define alpha. Actually, I'm going to put it in the next block of code. I'm going to use first the critical value approach. So I'm going to find the critical value. And for that, I do need the alpha. So I'll say the alpha. No, that's the significance level. The alpha is 0.05. I'm seeing a 0.05. Okay. So here is a question about the proportion. I'm going to be using a z-test. I'm going to be using the normal distribution to approximate the distribution of the sample proportion. Okay. Let's start. So this is a one-tailed test. It's in fact an upper tail, because here it says greater, so this is an upper tail test. So I'm going to have a positive critical value. So the critical value is going to be positive, so I need to put a negative there. And I'm going to use the Q norm, because I just said I'm going to use the C test, and I'm going to write just alpha there, and I have the critical value. I don't have to divide the alpha by 2 because this is just one tail test. So the alpha, the probability, I just want it in the upper tail. I need to, if I want to see the critical value, I'm going to ask for it. So right there I have my critical value. That's the critical value for this test. So now I can calculate the test statistic. So I'm going to calculate the test statistic. I'll test that. This one is the C test statistic because this is the normal distribution. And to calculate it, I'm going to be using a function or a formula that is specific for this. So that is going to be, first of all, I'm going to define what the population proportion is. What is the claim? So the population proportion claim is 0.26. I'm going to define it there. And now I'm ready to calculate the test statistic, which is a C stat. And it is equal to the sample proportion minus the pi divided by the square root. And now this is going to be pi times 1 minus pi. So this is my population proportion divided by the sample size. I need to make sure all my parentheses are in the right place. Everything looks good. And I'm ready to calculate. Something goes wrong. Okay, so right there I have my test statistic. So this test statistic is based on my sample. This is the critical value given my significance level. And what I can see is that my test statistic is no greater than my critical value. What I didn't do here is maybe I should write my decision rule based on the critical value. So the decision rule will say if the test statistic is, in this case, greater, because this is an upper tail test, so I have here greater than 1 point, and I'm going to round it, no, 1.65. Probably, if I want to be more precise, it should be 455. Then, if that is true, reject the null hypothesis. So that is the decision rule based on the critical value. I calculate my test statistic. Now I look at my test statistic and I see that it's not greater. So the decision rule is going to be, in this case, my decision conclusion, my statistical conclusion is going to be do not reject the null hypothesis. So if I'm not rejecting the null hypothesis, so I come here and I'm not rejecting, what I'm saying is that I don't have enough evidence in support of the alternative. So there is insufficient evidence that the Chrome market share at the university is greater than 26% at the 5% significance level. Now, so what I'm saying is that, okay, at the 5% significance level, I do not have enough evidence to conclude that the difference that I see, you know, the 30%, which is greater than the 26%, is enough for me to conclude that at the population level, the market share is greater than 26%. If we use the p-value approach, so now let me calculate the p-value. So I'll do the p-value approach. So this is an alternative. We're going to get the same, sort of the same result. If we want, we can write what is the decision rule for the p-value approach. So the decision rule is going to be if the p-value is less than, in this case, 0.05, the significance level, we are going to say reject the null hypothesis. So now let's calculate the p-value. So here in the p-value, we're calculating the probability of collecting a sample and observing a sample proportion of 30% or more. So the p-value is going to be equal to, this is a one-tailed test. So the p-value, and it's an upper tail, so it's going to be 1 minus norm, actually p-norm, I'm calculating a probability, p-norm, my test. I'm not using the right notation. So underscore. Okay, so now I can. All right, so here I have the p-value for my test, and is almost 10%, 0.09. So this is clearly greater than my significance level. So the decision rule, the statistical conclusion, I mean, is also the same. So the statistical conclusion is do not reject the null hypothesis. That's not surprising because they are the critical value approach and the p-value approach, they're equivalent. They're always going to lead to the same statistical conclusion, always the same conclusion. It's just two different ways or two different paths to reach to the same answer, to answer the question. And now let's say if we want to use the prop test function in R. Well, we can use that function. So the way that we write this function, so let's make some room here for it. So the function is prop test. And now what we need to do is give it the number. So we can see here what are the things that we need to provide. We need to give this the number of yeses, the number in the sample. So I'm going to say N for Chrome, N for the size, I need to also give the value of the P. It might be a good idea to check always the instructions. I always feel like I need to check, make sure that I'm using the right syntax. And what else do we need? Confidence level. So the confidence level is going to be 1 minus alpha. So in this case is 95. And then we can run the test. We might have to fix something if we put something wrong. So let's do that. I'm going to look for my so it's not pi, it's p. Minor detail. Okay, and here we have the result. So this one is not exactly a z-test, it's using a slightly different calculation, but the results most of the time are going to be very consistent. So we had the null probability was 0.25, that was information that we gave it. It's given us the p-value, and the p-value is slightly larger than the one that we had, but is in accordance with our conclusion. So the alternative was that the true p is greater than 0.25. Given that the p-value is greater than 0.05, we will reach the same statistical conclusion of do not reject the null hypothesis. We don't have sufficient evidence to conclude that the Chrome market share at the university is greater than 20. Okay, so that concludes this video. Let me know if you have any questions.